Okay, so let's make our list. Just recap. So the cannon's 3.2 meters high, right? Is that 3.2 meters, is that in the x direction or the y direction?
Y.
The y. Is that 3.2 meters, is that an initial y or a final y?
Initial.
Initial. Why is it an initial y? That's where we start. The reason why I bring it up is because sometimes students say, well, we always start at 0, right? So they always think the initial is 0. But you got to look at our situation. Here the cannon starts 3.2 meters above the surface of the water. That's our initial, 3.2. Our final is the surface of the water, right? Where we have the splash?
Yeah.
So what's that height? 0. What else do we know in the y direction? Gravity. What's gravity? Gravity is a force. We're not doing any forces. Acceleration due to gravity. What is that? 9.8 meters per second squared. That's why it's helpful that I drew the up and the right arrow on my sail, right? Because those are the positive directions.
I have another bag of these.
Yeah. Nice. Sounds like you have some willpower issues there. All right. Initial final would be a willpower issue. Initial final acceleration. Anything else we know in the y direction? Scott, you made a point of saying it's shot completely horizontal. Why is that important?
Because the y direction doesn't matter.
The y direction does matter.
There's none.
There's none what?
There's no y direction.
What about the y? There is a y direction. There's no what in the y direction. Be a little more specific here.
Magnitude,
Nope.
acceleration.
Nope. Someone help Skylar out? No? There's no what in the y direction? Velocity, right? Because we're shot horizontal. Okay? That means the angle here is 0, which means that there isn't really a hypotenuse here. The hypotenuse is really just the horizontal leg of our triangle. Right? Which means there's no vertical leg. So our initial velocity is completely horizontal, which means the y component is? Okay, do you see why what you're saying wasn't helpful with the... Okay, because the y direction does matter, it is important, but there's no velocity in the y direction, which is I think is what you're getting at, but I want a little more of it. Now, when we hit the water, or the moment before the cannonball hits the water, the cannonball is going to be traveling at this angle. Will there be a y component there? Will there be a y component of this velocity?
Yes.
Yeah. If I look, we could have this be the x component, right? So is there a y component? Yeah, the y component would be this right here. So is our v final in the y direction 0? No. Do we know that v final?
No.
No. We do not. The bottom of the ocean does not, because once it hits the water, it's no longer projectile motion. It's now forces and fluid friction and a bunch of other stuff going on.
But what if
And fishes.
the wave were to come up? Just take the cannonball and
We're assuming there's no, the waves are negligible. Okay, very small waves.
But you drew it.
you did.
Yeah, they're negligible. Here we go.
What about strong gust of wind?
The wind only plays a small part in waves. It's more where the moon's located at the time of day. Okay. Anything else for the y direction? Do we know time?
No.
No. What the x direction? What do we know? Good. A little more specific, please. What?
Distance final.
What's distance final? 8.5. Good. What's distance initial then?
0.
0. All depends on the situation because we're starting at 0 or 8.5 meters away. Oh man. Anything else we know?
Acceleration 0.
Acceleration 0. Good. Is it always 0 in the x direction, Kyle?
Yeah.
Yes. Unless we're considering air resistance, which we are not. Nice job, Kyle. Anything else? Is there initial velocity? Yes, but we don't know it. Is there a final velocity?
Yes, but we don't know.
How does it relate to the initial velocity? They're the same because there's no acceleration.
They're cousins.
Nope, they're exactly the same. Okay. Because there's no acceleration. Do you know time in the x direction? No. So, which direction should we start with, x or y?
Probably Y.
Okay. So you want to start with y or x? Y. WHY. Because we have more stuff. We have a lot more info in the y direction.
That's what I was talking
Okay. More stuff. Yep. Okay. Also, if we look at our equations, hi George. If we look at our equations, right? Which equation could I apply to the y direction right now to find something that I'm missing?
Equation 3.
Let me rephrase this. In this problem, we're trying to figure out this launch velocity, right?
Yeah.
So the launch velocity comes from the horizontal direction, doesn't it? We have two unknowns in the horizontal direction. One of them is the launch velocity. The other one is the time. So if I want to find the launch velocity, I need to figure out the time. Does time in the y affect time in the x?
Yeah.
Yeah, because they are both equal. They are not a vector, but a scalar quantity. So the time in the x is the same as the time in the y. So if we can use this y direction to find the time, we can figure out the velocity in the x. Does that make sense? So now looking at our list of equations, okay, which equation will let me find the y direct or the time in the y direction? 1, 2, 3, 4, 5, or 6. Which one?
No,
3. Good. You were right, Rex. And then you quickly backed off. I didn't get it. Okay. So equation 3. D equals 1/2 AT squared plus V naught T plus D naught. This equation, using the y direction, will help me find my time. Right? Does that make sense? No, why not? What? You don't comprehend. Okay. We know D, right? 0.
Yeah.
D naught 3.2. Acceleration -9.8. V naught 0, right? V does not make an appearance in this equation, which is why we picked it, because we do not know this, right?
Yeah.
And since we don't know this, we need to pick an equation that doesn't have that. It has T, right? But we're trying to find T. By finding T and the Y, we then can use that T to find the velocity in the x. Okay? So, D is 0. 1/2 times -9.8. T squared plus 0t plus 3.2. Right? I plug in everything from that list. Does that make sense?
Yeah.
What's 1/2 times -9.8? 4.9. -4.9 t squared plus 3.2 equals 0. What should we do now? Algebra. Subtract 3.2. -3.2 equals -4.9 t squared. Omar then said divide by -4.9. -3.2 divided by -4.9. What do we get? A number. A wonderful number. Less than 1.
0.65306.
Okay. Equals t squared, right? Yeah. So that means it takes 0.65 seconds. We have to square root it. So square root 0.65 and we get 0.8.
Ooh, I did that in my head.
Rex, you're just so good at guessing.
No, that wasn't a guess. I did
No,
like 64.
Yeah, it's close to 64. Nice job, Rex. Good job with the mental math. Nice. Must be the Sour Patch Kids. 0.8 equals t. Does that make sense?
Yeah. No.
So now we found our time. So where can we put the time? This time goes for this t and the other t, because time is a scalar, does not depend on direction. Right? So then, using my x list,
We can theoretically find some more stuff.
no, we can actually find it. Okay. So we know acceleration is 0, so we should stay away from equations that have acceleration, right? So look at our list. Find any equation that does not have an acceleration in it.
5.
Which one is it? 5. So the equation we need to find our x velocity is this. D equals, oops, 2 equal signs.
That chord is like directly in the way.
That just sucks. doesn't
I'm sorry, Rex. So D equals VT plus D naught, right?
Yep.
D is 8.5. So the cannonball lands 8.5 meters away. V we do not know. T is 0.8. D naught is, oops. D naught is 0 because we start 0. So how do I find velocity? How do we find velocity? I'll simplify it for you. Use everybody's favorite L.
Divide.
Divide. Good. Divide by what?
0.8.
0.8. Okay, everybody's favorite L. Algebra. Ah! Good jokes.
Good one.
I got a joke book for Christmas.
I actually never heard that.
8.5 divided by 0.8. What is that? It's gonna be more than 1. More than 10. What is it?
10.6.
10.6. So that means that this cannon is launched with an initial velocity of 10.6 meters per second squared, right? Right?
Yeah.
What is the x component when it hits the water? No. Just before it's the water. Sorry. The moment right before it's the water. So the first little atom on the cannonball, just about to hit that first little atom of the water.
But what if the water's
10.6. How do you know, Kyle?
Because it's constant.
Why is it constant?
Because acceleration is 0.
Good. Acceleration is 0 in the x direction. So that 10.6 we have horizontally to start is the same thing we have here at the end.
What if the water just splashed a little bit when the atoms touch the cannonball?
Then it'll slow down just a little bit. All right. Next part of this question. What is the speed of the cannonball when it hits the water? Right? So we are going to zoom in on this picture right here. Okay? Kyle told us, can't talk, that this x component right here is 10.6, right? Right?
Yeah.
Now, we also have a green vector which represents our y. And the black vector is the hypotenuse. This is our, nope. That's our actual velocity, right? Or our actual speed. This is the x component. This is the y component. Right? We want to find the actual speed, right?
Yeah.
So I zoomed in on that picture. Is there anything else in this picture that we know or can find?
We know 90.
Yeah,
90.
why?
Okay, we know it's a 90 degree. We can find Vy?
I think we know it. No.
We do not know it.
But we can find
It's right here, right? We didn't know it. Could we find it though?
Yeah.
We have an acceleration, right? Right? We have a time. We have an initial velocity. Can we find a final velocity?
Yeah.
What equation?
Yeah, 6.
Nope. Nope. 4, good. I knew we'd get there eventually. V equals V naught plus AT. Right? What's V naught?
I can't see.
The initial y component. 0. What's acceleration?
Negative.
There you go. What's D? We do too know? 0.8. So negative 9.8 times 0.8, what do we get?
Can you not find 8 in the bottom in black?
Negative 7.8.
That makes me know that it's a good one. Because the whole rest of them is.
Gotcha. What is it, Jose?
Negative 7.8.
Negative 7.8. So V equals negative 7.8 meters per second.
Good job.
That negative 7 means it's traveling which way? Down. So when we put it in this triangle, we already have the green vector pointing down, so we keep the negative sign? No. So now I have a right triangle, which I know two legs.
You can do a little bit of
Can we find that hypotenuse?
Yeah.
Yeah, how?
little bit of Pythagorean.
The Pythagorean theorem, which is what, Omar?
Number
A squared plus B squared plus C squared. Or V squared, or that, right? What? I'm not changing it, it's just the same thing, I just have plugged in what they are.
Changing the variable.
Not changing the variables, I'm substituting. Which in essence is changing. It's like in hockey, we did a line change.
Tell me about it.
You missed a good Winter Classic yesterday. Alright. So V squared equals 10.6 squared plus 7.8 squared. Right?
Nice.
So V equals the square root of 10.6 squared plus 7.8 squared.
13.
The answer is 13.16. Okay.
Put the one before that.
176 point what?
173.
0.2.
Yeah. What he said.
Okay. And the velocity then is 13 point,
160,547.
we'll call it 2.
It's important that you add
That means that at the moment before impact, the cannonball is traveling 13.2 meters per second.
all. Sure.
Does that make sense?
Yeah.
Are there any questions?
No.
Is that a good review of what we did before break?
Well,